Okay, so how to solve the areas of sector and lengths of an arc in a circle. So in this type of questions where it has been given is mm, calculate the length of arc AB in the sector below. So here we have to calculate only the length of the arc. So we don't have to calculate the whole perimeter around this sector. Rather, we have to calculate the length of arc. So here in the question, first question A, the length of arc is from this A to this B. So we have to calculate only this length. So we have been given here the R radius is 12 and the angle has been given is 80 degrees. So when we have to find the length of a circumference, the circumference of whole of a circle, the formula with us is C is equal to pi d. So this is the formula and d is the diameter. So now we have been asked to find only this portion, right? So if we have got some portion of this whole circle, it's not complete circle, it's just some portion. So what we are going to do is we have to find that what is this portion out of whole 360. So in a circle, the area around this is 360, so this is just 80 degrees with us. So what we are going to do here is 80 divided by 360, and rest of the formula remains the same, pi and d. Okay, so now d is diameter. Diameter is double of the radius. So if the radius from this side to this side is 12, so d diameter would be uh, 24, because if this is 12 and other side there is also a 12, so 12 plus 12, the d should be 24. So we now write this is, so that makes 80 divided by 360, and we write the value of pi is 3.14 and d is 24, right? So this should give us the length of this arc AB. So let's calculate this one here. Okay, so 80 divided by 360, this gives us this one, and then times 3.14 times, and diameter with us is 24, so 16.746. So we can write it as 16.75 because the next 6 is greater than 5, so we can change it into it says into a one decimal place. So if it's a one decimal place, then 16.7 is enough, right? So 16.7. So it's, if it's a 4 here, the next one, then we do not change this 7 into 8. If it was 5 or above, then we would have changed it. So the question says write your answer to one decimal place. So for one decimal place, this is okay. So in the same way, we have to find the length of arc of this one. We'll use the same 120 out of 360, and the radius is if 30, so we have to calculate the diameter and pi remains the same. And here in this question as well, uh, it's here the radius is if it's 60, that means the whole diameter 60 here as well. So you can just imagine the diameter will be 60 plus 60, 120. And the angle here is 210. So the length or the circumference of this arc from A to B, this would be something like 210 divided by 360, and pi, we have to write the value of the pi, and d is 120. So you should solve this one. Okay, in the next question number 2, it says that calculate the area of each sector below. So we have to calculate the area of each sector and give your answer to one decimal place. So if it's a one decimal place, then after the decimal, we have to just write one integer, one figure. And here in this one, we can see that uh, R, or the radius here, is 11 centimeter, and this one is 45 is the angle here. For area of a whole circle, the formula with us is pi r square. So pi r square is the formula, but we do not have here a whole circle. We have just a portion or a sector of a circle. So this portion is 45 out of 360. So for this one, the formula with us would be 45 out of 360th portion, and rest of pi will be 3.14, and r will be 11, right? So 11 and square. So if we solve this question, right? So let's try to solve this question, and it gives us 45 divided by 360. This gives us 0.125, and then we time it with value of 3.14. The Okay, this gives us this answer, and then 11, the radius square. So 11s are 121. So we time it with 121. So this gives us 47.49. Now we have to write just one decimal, this 47.4, and the next decimal is 9. It's greater than 5. So we have to change this 4 into 5, and it will become 47.5. So our area will be 47.5 centimeter. Okay, so in the same way, you can solve other questions. Here you see 85. So 85 out of 360 times pi times here radius is 25, so 25 square, and here to find the area. So if this one is here angle given to us, it's 60, so we need this angle inside. So the whole angle in a circle is 360, so the inner angle will be 300. This angle is 60, so this angle is 300, and the radius here is 15, as we already know. So the area here we can calculate is 300 out of total 360 pi, and then r here is 15 centimeter, so 15 and then square. Okay, so this is how we can solve this question. And in the next question here, in each of the diagram below, the length of arc AB is given. So the length here, we have already been given the length of this arc, 12.56 centimeter. Calculate the size of the angle at the center of the sector. We have to find this angle. Give your answer correct to the nearest degree. So we have to write it to the nearest degree. Okay. So the formula with us is right? So for a circumference of an arc is angle divided by 360 times pi and times d. This is our formula. So now we have to find this angle, this one, theta. So we take everything else to other side of the equation. So the C circumference of this arc has already been given to us, 12.56. So we write it is 12.56, and then this 360 is dividing here. When it goes to other side of the equation, it will time. So it will time 360 with this c. The value of c is 12.56, and then this pi and d, they are in the numerator. So when they go to other side of the equation, they will go to the denominator, right? So now pi value we straight away write 3.14, and d here, if the radius of this is 12, so that means the diameter is double of the radius. So radius is if 12, so diameter will be 24. So this one should give us now the angle theta. So we try to solve this question here. Okay, so 12.56 times 360, and this gives us this one, and then we divide this answer by 3.14, gives us this answer, and then we again divide it with 24, divide with 24, so this gives us 60. So the angle here is 60 degrees. Okay, so in the same way you can find the angle here as well. So the arc length has already been given to you, this length 146.5 mm. Okay, so in the same way you can write 146.5 is equal to theta over 360 n times pi n times d should be, if this radius is 60, so 60 times 2 is 120. 120. So if you solve this equation, take everything other than this theta, other side of the equation, and then you can find the angle. So in the same way, in this question also, it's the same. You see, this arc has been given to you, this whole arc has been given to you, it's 122. So it will be like 122 is equal to theta over 360 times pi, and d is 25 times 2 is 50. So if you solve this one, you can straight away find the angle as well. And in question number 4, it says in each of the diagrams below, the area of sector is given. So we have been given this as an area already, right? So the area is already given. Calculate the size of the angle. So previously we were given the arc length. So the arc outside the arc we were given. Now we are given the area, and we have to find this angle here. It remains the same. We have to use the formula of the area. Previously we used the formula of the arc, but now we have to use the formula of the area. And the formula of area normally of a whole circle, the formula is pi r square, right? But here, so here we do not have a whole of a circle. We have just a sector here, a small sector here. So we have to write this portion is theta out of 360. So this is an angle out of 360, this unknown angle which we need to know. So the area already given 120 is equal to theta over 360. The value of pi we already know 3.14, and the r is 14. So we have 14 square. Okay, so now we take everything other than this theta to other side of the equation. We isolate this theta to find the value of this angle. So this 360 is dividing here. When it go to other side of the equation, it will time. So 120 times 360 divided by 3.14 is multiplying here its operator, so it will go down and divide 3.14, and then 14 times 14 will is also multiplying here. When it go to other side of the equation, it will also divide with it. So 14 times 14 gives us 196. So 196. So this should give us the angle theta. So let's try to just simply calculate this one. 120 times 360 makes this one, and we divide this with 3.14, gives us this answer, and we again divided 196 divided by 196, so it gives us 70.19. So it says us to give your answer to the nearest degree, so we have to just write the degree. This one is 0.19, right? So 1 is less than 4, or if it's greater than 5, we can just write 71, but we do not need to just write 71. That angle is just 70 degree. We do not need to write the points. So in the same way, you can calculate these two questions as well. Okay, so the area has here already been given to us, and the radius has already been given to us here. So using the same formula is 506 is the area, is equal to uh, theta over 360, pi, and r square is 20 square, right? So now in this one, you move everything other than this theta to other side of the equation, you can find the angle. And here as well, the same, we have been given the area of this one, and the radius has been given here, so we can just put this formula and solve this question. So thank you very much for watching the video.